So the first part of 6.1 is going to be simplifying fractions. Really, we're going to simplify rational equations or rational expressions, which are just fractions. And then tomorrow I'm going to do the second half of 6.1, which is multiplying and dividing. But I don't want to get to multiplying and dividing until you know how to simplify, because the hard part of multiplying and dividing fractions is simplifying fractions. Okay, so that's why I'm gonna stick to today covering just simplifying them. And we're gonna do a lot of examples. It might not take the whole hour and 15 minutes, but we're gonna do a lot of examples till they just get kind of boring, which is what they need to be. They need to be a reflex so we can easily do the next 3 sections. So 6.1 is going to be simplifying these things and multiplying and dividing. 6.3 is going to be simplifying complex fractions, which are like fractions inside of fractions. And then 6.4 is the easiest section. It's solving these. Just like factoring, how the factoring sections, if you look over them and did well, you notice at the end the solving part was the easy part. The same thing is true with fractions. If you come to an example with a fraction and an equation, it turns out it's pretty easy because you can get rid of the fraction pretty quickly. So let's get started today. Are there any questions about anything overall before I get started? I mean, anything. It doesn't matter. It doesn't have to be math related. It can be school related. I am okay for any questions. Oh, I did find the first test. So if you go in, you can see your grade on the first test. Now you can't see the test. I'm trying to figure out how to import the test back in, but for now we've got the grades at least, okay? Any questions before you rock and roll? Okay, I'm gonna switch to a little document camera that I'm pretty proud of that Mr. Franklin, oh wait, how did your, oh, my really long test went as good as it could go, I guess. Yeah, I took a test from like 9 a.m. to about 3 or 4 p.m. on Friday. So what that does, if I pass those, then I go on to dissertation. And then once I get done with my dissertation in about 1.5 years or so, I'll be a doctor and I'll force all of you to call me Dr. Shirley. No, I won't be upset about it. But then, so yeah, I think I did well. I won't know for like another month, Janie, though. I'll keep you updated because we'll be in class together for at least another month. Okay. Okay, so let's get 6.1 rocking and rolling. And if you guys do have a question, just ask me. It's no big deal. Okay, let me move the. I tried to do where like you can see me and the document camera, but it's been glitching. I'm gonna try it again real fast. And I can't see you when I do this, so I need you to just turn on your mics and tell me if I'm glitching when I do this. Hold on, let me. Advanced sharing options, that's not what I want to do. There we go. Advanced content from second camera. Share. Okay, whoop. All right, see how I'm glitching? Do you guys see that on your side?
Yeah, it's lagging a little bit.
Isn't that weird? I don't know why. So yeah, let me get off this. Stop sharing. Okay, so let me just switch it to my camera, change cameras. If that's the weirdest thing that happens, that's not the big deal. Okay. Get that thing in focus. Boom. So 6.1, rational equations. It's really rational expressions. It's going to bother me. I'll put that. So rational expressions because there's not an equal sign. Okay. So before we get to simplifying, that's what 6.1 is going to be about. Today, we're going to learn how to simplify these rational expressions, okay? And before we simplify rational expressions, I'm going to show you how to simplify fractions in the same way we're going to simplify these rational expressions. So I'm going to go back to some basic fractional stuff. Now, this is probably different than how you might have learned how to simplify numerical fractions when you were, in K-12, but this is the way I'm going to kind of turn this into higher level of simplifying. So let's say I've got 8 divided by 14. And I want to simplify 8 divided by 14. You know what? I'm going to make this not 8. Hold on. I'm sorry, guys. Let's do 10 divided by 14. 10 divided by 14, I want to simplify. Hopefully, I'm hoping everyone in this class goes, hey, they're both divisible by 2. You can divide 2 on top and bottom, boom, it's just 5/7. And that's great. But the idea of simplifying really comes from factoring, okay? We've got to factor the top and bottom completely and see if we have common factors. So if you factor the top, 10 becomes 2 times 5, right? That is 10 factored, right? We factored into 2 multiples, 2 times 5. 14 turns into 2 times 7, okay? It's completely factored. Then you just cancel. Remember, we talked about this in the exponential section. You just cancel common factors, right? 2 is a common factor. That's why we really go about dividing them by 2 on top and bottom. And it turns into 5/7, right? Kind of neat, okay? So if we had something, let's say, let's go back to that 8 divided by, let's say 8 divided by 20. And again, I'm hoping you're thinking, hey, they're both divisible by 2 or 4. I can divide them out. But I'm going to kind of show you what we're going to do today. We're going to factor both of these completely. Now with numbers, you would use a factor tree. Look, we're not factoring numbers today. But with the numbers, you could use a factor tree and say, you know, 8 is 4 times 2. 4 is 2 times 2. I'm not sure if you guys remember how to do this from way back. So it turns out 8 is just 2 times 2 times 2. Okay? 20, if we did 20, I know it's 10 times 2. I'm circling them if they're prime. You haven't seen this in a while, okay? And then 10 isn't prime. It can be broken down into 5 times 2. So 5 becomes 5 times 2 times 2, okay? And this is this is like how you learn how to simplify fractions at the very beginning, but then you learn kind of easier tricks after. Okay, and then notice we've got pairs of 2's we can cancel. We can cancel this 2 with this 2, this 2 with that 2. And we're left with 2/5, right? These don't cancel because they're different. Okay? Same thing. Now, I'll tell you what we're going to do today. Same thing, just with expressions, with binomials and trinomials. Binomials and trinomials. Okay? So let's get to actually what I'm talking about today. So the goal today is going to be to simplify expressions. And really, there's just 2 steps. You're going to factor the numerator and denominator completely. Completely. Is it like that? There might be an E in there. I don't know. Another E. Factor the denominator and numerator completely, and then cancel common factors. That's exactly what we did here, okay? We factored the numerator and denominators completely, and then we canceled common factors. That's all we did. But now we're going to do it with binomials and trinomials, okay? So let's look at a very, very kind of basic example before we get started. Well, let's do one with numbers. Let's say we've got, guys, I'm going to be doing a lot of examples today. So let's look at, let's say we had 2x squared over 4x minus 6. 2x squared over 4x minus 6. And we're going to break these down. You got to think of numerator and then denominator, okay? So I'm going to look at the numerator first. And I'm going to say, look, can I factor this 2x squared at all? No, I can't factor anything out. It's a single term. Single terms can't factor. Now, you might be able to factor the number like we did with the 10, making it, you know, like 5 times 2. But we're not going to worry about that. We're going to just look at the entire numerator and say, hey, there's nothing that factors how we learned how to factor in chapter 5, the last test, right? So then we're going to look at the denominator. And we're going to say, hey, if I give you 4x minus 6, what could you factor? Well, it's not a binomial. It's not a difference of squares. We can't go that route. But we can factor out a GCF, right? We can factor a 2 out of that denominator because both 4 and 6 have a 2. They can come out. So we get 2x squared over 2 times. Now, if you remember back from 5.4, this means this will be 2x minus 3. And then look, this 2 is being multiplied up top. This 2 is being multiplied in the denominator. I'm going to take my red pen out. That means they can cancel. So therefore, we're left with, I'm going to move it. I feel like I'm writing goofy. But this winds up being x squared over 2x minus 3. Now, you're more than welcome to leave the parentheses. I kind of like that habit, but you don't have to leave the parentheses. And the way you can kind of check that you're done at the very end is look to see if there's a common factor in all of them, right? Look, x squared, x, and 3. Remember, there's 3 parts to this fraction, right? We've got the numerator. We've got 2 parts in the denominator. There's nothing that factors into all 3 of those parts. Please, 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 please. Look, hold on. Watch this. Hold on. I'm going to switch back to me. Please, okay? Please do not tell me in this expression that you can cancel an x out. So I'm going to go back. I needed you to see my face. Oh, there's my face over here on my laptop screen. Boom. Please do not tell me you can cancel those x's out. And the reason you can't cancel the x's out is because there's a minus 3 over here. You'd have to have an x on that 3 as well, okay? If we had that, then we would have canceled an x out of the whole thing. We'll do that on the next example. I'll show you what I'm talking about. So let's say I've got 3x to the 4th over 6x squared plus 9x cubed, okay? And right now, but before we get started, I can tell you, look, I got all 3 of these are divisible by 3. Do you see that? And then I can tell that all of them have x's. So there's going to be a lot of canceling going on. Let's just show you how that happens. Okay, I'm going to break this down probably a little further than I would once we get rocking and rolling and see these kind of patterns. But in the numerator, I've got 3x to the 4th. Again, I can't factor anything out of that because it is what it is. Okay, I'm going to move this just a little bit. There we go, a little easier to write. But in the denominator, I'm going to put parentheses around it because it kind of lets me know, hey, I need to factor something out. Well, I can factor a 3 out. It's going to cancel with that 3. But I can also factor an x squared out, right? We learned that in 5.4. Everything's building on itself. I can't factor an x cubed out because this first term only has 2 x's. So when I factor that 3x squared out, the first term completely, well, I factor the 2 x's out. They're gone. And I need a 2 there, right? 3 times 2 would give me the 6. X squared leaves me with the x squared. The second term, though, I factor the 3 out, and I'm left with a 3. But I only factor 2 x's out. There's 3 x's there, so there's an x left over. Okay? Okay. So now I'm going to look to see what I can cancel out, because really I've got 3 things being multiplied on the bottom, right? I've got the 3, I've got the x squared, and then I have the binomial. You guys see that? And on the top, I just have the 3 and the x to the 4th. Hey, we went over that exponential section, so I know how to divide x to the 4th and x squared, but let's get rid of the 3's first, right? They're going to go away. But I got x to the 4th and x squared on the bottom. Now remember, if I've got exponentials, that means I just subtract the exponents, 4 minus 2. So these are going to go away, but then this leaves me with 2 up top because I subtracted the exponential. So now let's see what's left overall. On top, we're left with the x squared. On the bottom, we're left with 2 plus 3x. That's kind of neat. Okay? 2 plus 3x. Now look. So let's see here. If you look at all 3 terms, x squared, 2, and 3x, there's not a common factor. Okay? We don't have a common factor. We can't cancel anything else out. It's a good way to think of it. Okay? How we know we're done factoring. Any questions before I keep building? So what's going to happen is I'm going to, in a weird way, the The factoring is going to get harder. The simplifying is going to get easier. Okay. That's how this moving forward, how this section kind of goes. Okay.
I have a question real quick.
I want you to try this one. I'm stealing it straight from the book. I'm going to pause the time so you can try it. So 2x squared over 10x cubed. Can you guys see that? Yeah. Minus 2x squared. I like this example. I'm going to pause it real fast. Pause. Hey guys, if you're back from being paused and you're watching this video later, we worked through this one. I factored the 2x squared out of top and bottom, and then it leaves you with 1 in the numerator and then 5x minus 1 in the denominator. I forgot to hit the record button. But no, that was a great question, Janie, though. People watching this later should have been in class. Got a good question. Missed a good question. Okay, I've got to go over a goofy little trick that your book loves doing, and it's quite annoying. But you're gonna see it maybe on the test. You're definitely gonna see it in the homework. And I just want to go over why we just need to go over it. All right. So the trick looks like this. I'm going to give you the rule first. If we have a minus b, okay, and we need to flip it for some reason, if we need the b to be here and the a to be here, okay, what you can do is factor out a negative. And when you do that, it flips this. Now, the reason behind that is because when you factor out a negative, all you're doing is changing the sign. So you can turn me off right now if you don't want to see the reason, but I feel like I have to show you. If we factor out a -1, what's happening is this becomes negative a plus b. The signs change, right? I think if I multiply this back through, -1 times negative a gives me the positive a, -1 times b gives me the negative b, right? So I factored it out. And then because it's addition, we can use the commutative property that says we can move it around. So this can be written as b minus a, okay? That's the reason, but realize you don't have to memorize the reason per se. We just have to know, or don't we have to know, it's just a rule to kind of have back there like, hey, if I need to move this around to get it simplified, I can do that. And I'll give you an example. So here's a good kind of basic example. And what if we have two terms on top and bottom? If I've got, let's say, x minus 2 over 2 minus x. And I'm going to tell you, the very first thing I do on these is put parentheses around them. It keeps me situated on what I factored out. It keeps me situated on what can cancel, what can't cancel, what cannot cancel. So I would get in the habit of making parentheses. Now notice, this numerator and denominator are not the same, right? I mean, think if x was a number. If it was like 7. 7 minus 2 is not the same as 2 minus 7. But if I can rotate the x there and the 2 there, it'll match the denominator. Do you guys see that? It'll become 2 minus x. So I'm going to use this handy dandy rule that I just went over, okay? Oh my gosh. Mickey Mouse Clubhouse, hot dog, anyway, if you have kids or something that having to watch that over and over again. But we're going to use that in the toolbox, right? So I'm going to take the negative out, and we get 2 minus x, right? That's the rule. So a minus b, take the negative out, it just flips b minus a. So x minus 2 becomes 2 minus x. And that's what we wanted because the bottom is already 2 minus x, right? Kind of neat. And then now look, so we haven't done one like this yet, but look, we got binomials now that match. So everything's going away for this one. This is going to go away with this entire binomial. The only thing left is this negative, right? I mean, here's what's really happening. The only thing left is the negative. Everything goes, so it's -1 on top. If everything goes in the denominator, there's also just a +1. So this winds up being -1, okay? That winds up being -1. And I did that really just to show you how when you flip them, you can cancel. We're going to go now into more, well, what if we have binomials cancel with binomials? How do we do that? Okay. So I'm going to come back to examples that have this in it, but just give me a minute and we'll be fine. Let me find a good example. I'm trying to kind of explain. Oh yeah, here we go. A great example. Let's say we've got 6 plus, oh, this is a horrible example. Hold on. Let me think of a good one. Okay, yeah. Let's say we've got 6y minus 18 over 2y minus 6. So again, the very first thing I'm going to do before I do anything is put parentheses around the numerator and the denominator, okay? Groups them together. Let you know, hey, I need to focus on each of those groups first before I simplify in the end. Because remember, hold on, let's go back to this. Step 1 is factoring the numerator and denominator completely, right? The examples we've done so far, we haven't had to factor really the numerators. That last goofy one was different, but we haven't had to factor the numerators, just the denominator. So now we're going to factor numerator and denominator. So if we look at this numerator, we've got 6y minus 18. I can factor a 6 out, right? And I'm left with y minus 3. Ooh. And then the denominator, I can factor a 2 out. And I'm left with y minus 3. Hey, we can cancel those, right? We've got matching factors, or we got matching binomials. That's the word I was going for. I can get rid of y minus 3. Hey, they match. If they didn't match, if it was like y plus 3 over y minus 3, couldn't cancel. But because they're the exact same binomials, they can go away. Now I'm left with 6 divided by 2. If you want to say, hey, we can go back to old school factoring and say it's 3 times 2. The 2's cancel, leaves you with 3. That's fine. But we also know that 6 divided by 2 is just 3. Okay? That's just 3. 6 divided by 2 is just 3. Okay? Questions? We're going to keep building on this. So if I've got two, fraction on top and bottom, simplifying it, and then canceling out common or like terms. Okay, I want you to try this one. We've got, let's say 5 plus x over x squared minus 25. So I'm going to hit pause. Hopefully I'll remember to hit play. I forgot to put parentheses around the top. I can't factor anything out of the numerator, right? 5 and an x, nothing factors out. We're good. The denominator, though, hey, this is that special factoring, right? X squared minus 5 squared. And I know x squared minus 5 squared is difference of squares. So this winds up being 5 plus x over x minus 5, x plus 5, right? You guys remember that? Remember, if it was x squared minus 5 squared, we could write it as x plus 5, x minus 5. And remember, I think Amanda asked this, but there's, the order doesn't matter, right? Order doesn't matter. I'm going to write it just like this. Order doesn't matter. Now look, we don't have to use that cool trick that we just learned in the previous on the previous page, right? With the minus signs, because this is addition in both of these parentheses. 5 plus x, due to the commutative property, it's kind of hard to say, is the same as x plus 5. If you want me to write that out, I can, okay? This is 5 plus x, 5 plus 2 is the same as 2 plus 5, right? It doesn't matter which way you write it. But now we can cancel out the x plus 5s. Boom. Okay? Cancel out the x plus 5s. I'm going to write this underneath it. Everything goes away in the numerator, so we have to leave a 1. The denominator, we're left with x minus 5, right? We're left with x minus 5. That's our simplified solution, right? That's our simplified fraction. Okay. Questions before these just get harder and harder and harder and harder. And what's going to get harder is the stuff we were supposed to go learn in chapter 5. Okay. What gets harder is this factoring. So it's going to be just different kind of curveballs with factoring, and then just canceling what cancels in the top and bottom, okay? And I might even go over a new, one of the special factorings that I kind of glanced over, that I didn't even talk about. I'll probably go over that too, just because it pops up in this section. Question? Boom, okay, sweet, let's keep going. Okay, I'm going to give you a few of these, and remember, I just need you to factor these completely and then simplify. So I'm going to steal some even ones out of the homework. I might even steal some that aren't in the homework. This is number ooh, man, they jumped in the deep end in your homework. Okay, hold on. Let me look up another example. I'll call this example A. X squared minus 9x. Ooh, that's a minus 14, not a plus 14. All over x squared plus 2x minus 8. So try that one. And then for example B, I'll steal one from the homework here. This is number 26. Actually, man, I just don't like that one yet. Hold on, guys. Looking at some other examples over here from the internets. Yeah, let's do this. I know it's going to look more complicated, but it's not. A 3x squared minus 9xy. Oh, no. Oh, that's a horrible example. Ugh. Ugh. I'll try that one while I'm looking for another one. Trying to find ones I like to put on the test. Okay, so let's try this one. 25x squared minus 9 over 5x squared plus 7x minus 6. Okay, so try those two. I'm going to pause this because these will take a little bit of time. You've got to factor. I mean, there's 1, 2, 3, 4 expressions that you're going to have to factor completely. Okay, I do not expect that you're done yet, but I'm going to start working on these. So if you're working on the second one, just keep working and kind of glance up to make sure that the first one's done correctly. Now remember, if we've got an x squared by itself, we can do this the easy way. And I'm just looking for two things that multiply to get negative 14, add to get negative 9. Did I write this down wrong? Hold on. It should be a plus 14. I think. This is what you get for finding free examples on the internet. Hold on. Yeah, that's not how that factors. Yes, this should be a plus sign. Because this should be negative 2 and negative 7, right? And when you multiply that together, you get the positive 14. I'm looking at the example now on the internet, and they did it wrong. Oh, that's okay. And then we're going to divide that, though. And I'm going to do the same thing on the bottom. Let's see if they messed up on this one. No, they didn't. So x, we've got x and x, but now we've got a positive 4 and a minus 2, right? Multiplies to give me negative 8, adds to give me the positive 2 in the front. And then because after we factored it completely with the correct trinomial, we see that we've got x minus 2 on top and bottom, right? And then we can cancel that, and we're left with x minus 7 over x plus 4. Awesome, okay? So now look, do not tell me these x's cancel. Because remember, there's 4 terms in this entire fraction. And there are no x's on these 2 terms. So we cannot cancel these x's. It is the most common goofy mistake, I should say. Not goofy, just most common logical mistake, right? I'm gonna sit here and talk about why this is a common logical mistake if I haven't done this already, okay? one of the many reasons why we are the greatest of all animals is because our brain has the best pattern recognition of all the other brains, okay? And one of the things that can get us in trouble with this pattern recognition is when we see things that we think look like other things and they're not, right? This is why trick plays work so well in football or things of that nature, right? So here we've got a trick play going on. Our brain sees this x over x and it's thinking it's like fractions like, you know, like something like that, and you can cancel it. And it calls it 3/4, right? But the issue here is it's not just x. We've got grouping. So we have to subtract the 7 and add the 4 to that x. So we can't cancel it because it's not the same on top and bottom, okay? So your brain, in all its great power, is thinking, oh, I can cancel these because it looks like this over here. But it's not, because it's grouped first. Remember the whole order of operations. You got to do grouping first before you do anything else. That's why I like to, for you to guys put these parentheses there. Hopefully it kind of reminds you, hey, I can't cancel these because they're not, it's not a factor in all 4 parts for this one. You know, previously, once we got it canceled all the way down, let me give you an example. Like I'm talking about. Yeah, like over here. Like if we go back to here, we got x squared, 2 and 3x. Same thing. This x squared and this x can't cancel because the 2 doesn't have one, okay? And I'm repeatedly going over this because it's just a very common missed thing in this section, actually in future sections. So it kind of bites you if you don't get in the habit of saying, oh, wait a minute, there's a -7 and a +4. We can't do that. Okay, so that is that expression completely simplified. Any questions before I keep going? Okay, good. Now the numerator up here, this is difference of squares. I'm going to kind of do both these on the side. 25x squared minus 9, that's 5x squared minus 3 squared, right? And so since it's difference of squares, I know this is going to be 5x minus 3 and 5x plus 3. Okay? I had to notice it was difference of squares. The reason I thought difference of squares is the minus, or 2 terms first off, then a minus sign. And I thought, okay, well, let's see. Can I write that as something squared? Yep. Can I write the second part as something squared? Yep. And then it turned into that from, was it 5.6, that special factoring section. It turned into the difference of squares. Now the numerator, though, I've got to do the AC method on. Look, can't do the top method where I just set parentheses because this 5 is there, okay, and it doesn't go away. So 5 times -6 is -30. Is that +10, -3, right? Multiplies to give me -30, adds to give me the +7. So that's how I'm going to split apart this 7x. So 5x, so I'm going to put the -3x first because it puts the plus sign where it needs to be, right? So 5x squared minus 3x plus 10x minus 6. And again, we didn't violate anything. 10x minus 3x is just 7x, right? So we haven't done anything wrong. We've kind of unsimplified that number. And I've got the plus sign where I need it. So I'm going to put the fraction or the parentheses around the first 2 and the last 2, okay? And I'm going to factor an x out. And I'm left with 5x minus 3. And then I'm going to factor, I guess, a 2 out. That's 5x, yeah, 5x minus 3. So they match. Hey, that 5x minus 3 is going to cancel with that numerator. So I factor the 5x minus 3, and I'm left with x plus 2. So that took a while, guys. Remember I said the canceling is going to be easy. It's the factoring that's going to take a lot of time once we start rocking and rolling, and that's exactly what's happening. So 5x minus 3 times x plus 2. Woo! So that was the first step, right? If we go back, I know you guys are writing this real fast, but look, we go back, we factor the numerator and denominator completely. The next step for this one's going to be real easy. We just cancel what matches, right? The 5x minus 3 cancels with the 5x minus 3. And we're left with 5x plus 3 over x plus 2. Okay? And again, can't cancel those x's because I don't have x's over here. Okay. Any questions before I throw some? Actually, I'm going to go over this other special factoring that we didn't go over in 5.6. I just don't like including it on that test because I don't know why. In all honesty, I don't know why I don't go over it. But it's not a big deal. It doesn't pop up that much ever again in algebra. Okay, but it does pop up in this section. So remember we had difference of squares. That was the whole thing that we just did with that 25x squared and the 9. Well, there's also difference of cubes and addition of cubes. Difference. I'm spelling this completely wrong, I'm sure. Yeah, there's no way that's right. Oh, Lord. Of cubes and addition of cubes. Okay. Now, I'm going to go back to 5.6 in your book. It's on page, the rule actually is on page 393. Okay, so if you want to flip back, I'll kind of put the book over here for a second. If you go to page 393, you'll see at the very bottom, there's the, they call it the sum and difference. Ooh, I spelled that. Actually, I spelled it right. But there's the sum and difference of cubes right there. I'm going to write it down for you. And it says, look, if we have a cubed minus b cubed, we actually start with the addition of a and b. And then in the parentheses, we're going to have a squared minus ab plus b squared. Okay? And then if we have addition of cubes, a cubed plus b cubed, we start with subtraction, and then we have addition. A squared plus ab plus b squared. Now look, I'm not expecting you to memorize this because like our final, which I have to figure out how to do this, but our final is going to have to be proctored, but it'll still be multiple choice like the other tests. It's just going to be proctored, and you won't be able to use your books. Okay, it won't be open note and open book, but I will not put a difference or addition of cubes on the final. Okay, so if one of these pops up on the test, or if it pops up on the homework, realize you can use this rule. So my goal for this next example is just to show you how to use the rule. Okay, to show you how to use the rule, and I'm gonna start with the book in the next page actually. So if we look at something like a cubed plus 8, a cubed plus 8, the first thing we have to kind of realize is that we've got cubes going on. And remember, it's like things that are multiplied 3 times to get the number. So 8 would be 2 times 2 times 2, right? So this is actually x cubed plus 2 cubed. So we're going to use this rule, right? And look, we have addition, and we have our a and our b here. So if I wanted to factor this, I would factor into a minus b, so it's going to be x minus 2. And then I'm going to square the x, because it's a squared. Plus, I got to multiply them together, ab. Well, I'm going to write the 2 first, because we don't write it as x2, we write it as 2x. And then lastly, I'm going to square the b, so 2 squared, which we know that's 4. But I want to show you where it's coming from. So in the end, we wind up with x minus 2, x squared plus 2x plus 4. Okay? That's if we wanted to factor x cubed plus 8. Now let me find one in the homework. That's a subtraction. That's maybe a little goofier. I don't see any that are that goofy. Yeah. I don't see one in the homework that I really like, so I'm going to make one up here that might pop up. So let's say we had 27 x cubed minus, let's say 64. 27 minus x cubed. Now, the hardest part on these is recognizing that they're cubes, because we just don't do cubes as often, okay? So if you wanted to kind of make a chart, I'll do it over here. Kind of common cubes, right? 1 cubed is just 1, right? 1 times 1 times 1. 2 cubed is 8. 3 cubed, 3 times 3 is 9 times 3 is 27. 4 cubed, so 4 times 4 is 16, times 4 turns out to be 64. 5 cubed is, think of it like 5 quarters. So 5 times 5 is 25, times 5, that's $1.25. 6 cubed, I don't even know. I'd have to use a calculator. Hold on. You guys have a calculator handy right there next to you? If you want to put it in the chat for me, I'd appreciate it. I think it's 216. That's what I got in my calculator. Okay, so these are common cubes that pop up. Okay, so when we're working these, we kind of have to see like, hey, 1, 8, 27, 64, 125, and 216. If those pop up, I know I can write them as something cubed. So if I go back to my example, 27 is part of that. It's 3 cubed. So I could write this as 3x cubed. 64, I know 64 is 8 squared, but we're worried about cubes here. It's also 4 cubed, okay? And because of this, I can use the first rule. We've got difference of cubes going on. Here's our A, and here's our B. So we've got 3x minus 4, and then, oh wait, no, I'm sorry, plus 4, right? That's plus 4. And then we square the A minus, we got to multiply the A times the B plus the B squared, okay? That's a lot going on. Here's the 3 parts that we've got going on from this part of the factoring. So I've got 3x plus 4, that doesn't change. But now 3x squared, remember I have to square the 9 and the x from that exponential section. So 9x squared minus 12x, right, 4 times 3, plus 16. Boom. So that is the difference of cubes. So we've got an example of the addition of cubes and the difference of cubes, okay? And we're going to use them. And again, you don't have to have this memorized. It's on page 393 in your book. It's just knowing when you get something that fits this mold, how to write it as a factored trinomial, or a factored in factored form. We'll say it that way. So let's look at an example in this section though, where that pops up. This is, so now back to 6.1, where we get maybe a difference or addition of cubes, and we have to factor that difference or addition of cubes. Let's see, I'm going to go in the homework because I think I saw one in the homework. Oh, yes, I do, right there. Yeah, the even. Wait, no, it's odd. That's fine. So number 27, I'll be doing one of the odd ones. You should do this one though too. I'm going to sign up for homework. X cubed minus 125 over 2x minus 10. So I want you to try this one now. But realize that numerator is a subtraction of cubes, right? 125 is 5 cubed. I can write this as an x cubed minus 5 cubed and then factor it. So I'm going to pause it here. Play. Okay, so this turns out to be difference of cubes. Now I need this rule. I don't honestly teach it as in a memorization way. So that's why I've got to go back and use the rule. But I know this is really 5 cubed. So I'm going to think of it as this difference of cubes. So a plus b, so that's going to be x plus 5. Times a squared, so that's x squared, minus the a and the b multiplied together, so that's going to be 5x, not a. And then lastly, b squared. Now our b is 5, right? So I've got to square it here, and it becomes 25. All over. Now the denominator, I've got to factor a 2 out because they're both even, and I wind up with x minus 5. This doesn't cancel anything out. Oh, your book's wrong on this one. Huh. Well, this is a good example in a way, right? So we factored the 2 out of the denominator, and when we did that, it made 2x or x minus 5, but that's an x plus 5 up there. Can we keep going with the numerator? No, we can't factor this, guys. There's nothing we can multiply to get 25 and add to get -5, right? For 25, you'd have to do 5 times 5 or -5 times -5. Either one of those adds up to a -5. We would be done. This is it. Your book is wrong. Number 27 or 20, yeah, number 27. That homework problem is wrong. Because that would not cancel. You would have to have an x cubed plus 125 there for that to cancel. So wrong answer in textbook. Okay. Man, I should be making these textbooks. I'm making so much money, guys. I'm sitting here teaching. I could be making all this author money. Okay. Okay. So for homework, I want you guys to do 13. It's not going to be a lot today. There's going to be more tomorrow because we're going to get to the addition or multiplication division. I want you to do 13 through 32, and I want you to do all of them. And by all, I mean I want you to do the odds. And if you feel comfortable doing the odds, then I would switch to the evens. Okay. But that's so 13 through 32. It's on page 438. Okay. This is section 6.1. And we're going to continue. We're going to complete 6.1 tomorrow, like we had talked about. Let me switch this. Oh, here I am. Okay. Do you guys have any other questions about anything? About the semester? I've got to get the final stuff figured out because I don't know how we're going to do a proctored final. And if it worst comes to worst, I'll deal with it. But I've got to get that figured out now. It's right around the corner, which is crazy. Okay. Any questions? I'm going to finish the lecture and cancel it. I'll give you a few seconds to find the unmute button. 3, 2, 1. Okay.